for getting up early or staying up late, and coming out today. Today's an especially good day. It was kind of an accident, but I've got good news is that CouchDB 1.0 is released, and that's a major milestone. Damien Katz started on the project in 2005, and it's been in production in pretty heavy places, starting 2007, 2008. So it's really production ready now. So torture it, give it your best, and it'll keep up for you. So today we're going to talk about replication, which is just one of the features CouchDB offers, but there's enough to say about it that it's worth its own webcast. And I'll show you some technical, sort of like curl stuff and whatnot. But mostly I want to give you an idea of what you can do with replication, like what your appetite. And then there will be links at the end to the book and some other technical information, so that if you want to get in there and try these things out, it should be pretty easy. But before we dig into replication, first I just got to say 1.0. Sorry about your ears. But I just can't help myself. So 1.0, 0.11 came out a few months ago, and it's been a feature freeze. So there's not like a whole lot of new surprises in 1.0, but it is a lot faster. We did some tuning. We got, Erlang has some configuration stuff. We were able to make it be more multi-core, especially for I/O. So you're blocking less on the slow part of your computer and letting the fast part of your computer be fast. And the result is that red line there you see is much higher than the yellow line, and yellow is good in this case, or shorter is good. And so what we see is that the write throughput is drastically faster, and that's while it's being saturated with reads. And at the same time, the read throughput was just as good as on the previous version. So that's what happens when you benchmark stuff. Thanks Michael Rogers, who wrote that benchmark, and thanks Randall and Adam and everyone else who wrote that code and helped make the 300% faster happen. We also have Mark Hammond to thank for Windows support. I mean, he's not alone in that, but he did the big work on getting us to be a to support Windows as a first-class CouchDB platform. So now that we're 1.0, we can just be everywhere. It's not on this slide, but if you go to the Android marketplace on your Android phone and search for CouchDB, you can also get it installed there. That's just a developer preview right now, but we have Aaron Miller to thank for that. So it's really been a big community effort, and I'll say it one more time: 1.0. Hey, look, it looks like Boo-Rad's in the channel. Hey, Jan, do you want to say anything? Do you have your speaker set up? If you don't, you can just type it into the chatty dealy. But feel free to interject here. All right. Well, I guess Jan's just going to be relaxed guy for now. Yeah, we'll work on the whole Apple thing. I mean, technically, it's not hard. It's just a matter of getting it done. So we'll see. All right. So what are we going to talk about today? We're going to talk about the next page on these slides, which is just the outline. So I'm going to go over replication basics. If you've used CouchDB a lot, this won't be news to you, but if you haven't, this will be an eye-opener. We can talk about read scaling, because the part of the topic here is scaling, and you'll learn that there's easier ways to scale CouchDB for reads even than replication, even though you could use replication. Then we'll look at offline mode, which is our that's our really flagship use case. Talk about what you can do in offline mode, kind of what that feels like, and then also conflict resolution, which is really important when you have disconnected clients. Then clustering, because everybody wants to cluster, because we all think we're building a dragster. Okay, here's a quick poll for the chat room. Raise your hand if you're building a dragster. By that I mean like you're like relatively certain your website is going to be the size of Facebook. Because if you are, then CouchDB will be fine for you. But you're going to have to do the stuff we talk about in clustering. And then filtered replication is what I want to talk about last. I hope we have time to get there, because there's some amazing use cases around filtered replication. So I'm going to hopefully have a chance to dive into that. And that should be the most inspiring part if you're like, really someone who who has to write programs to do things, not just for fun, but because you have requirements. Nice. Soapbox racer. Cool. All right. So replication basics. You've got a couch, and now you've got another couch, and you want them to stay synchronized. That's what replication is for. So the the big thing to note about replication is just like the MapReduce queries, it's incremental. So that you do replication once, and it synchronizes the stuff from couch A to couch B, and then when you trigger it again later, it does the same thing, but it's efficient. It's not going to send stuff that couch B already knows about. And the same thing holds. Take that, and that's not super fancy. You can do that with MySQL. You can do that with other databases. But take that and put it onto a mesh of hundreds of ad hoc couches replicating with whoever, and the same principle holds. So that's replication. We'll see how powerful it can be. So if you want, go ahead and if you've got a CouchDB set up, you can run a command like that with the source and the target. That's just curl doing a post with a JSON body to that underscore replicate endpoint with the source and the target. That's a good question about surviving restart. I'll come back to that. So source is any, either the source or the target can be any URL, and those URLs can be absolute or relative. So the target in this slide is local DB, and that's relative. I mean, in the sense that it is on localhost in this case. If we were curl-x posting to something other than localhost, then the target would be on that host. So that's just the replicator replicating to a local database. The source is another HTTP URL, and I put in there, just to be clear about how you do authentication, I put in there the basic auth, the basic auth URL parameters, so name, pass @ hostname. So that's how you would replicate from a protected CouchDB if you had the read control, access control turned on. There is another parameter that we've added called continuous, which will take that replication, and instead of running it once to completion and waiting for you to trigger it again, it will run it once to completion, and then anytime anything happens on the target database, or on the source database rather, it will replicate that. Brian, I think you may be right that they don't survive restart. Jan can fact check me on that. We have, you got to hold something back for 1.1, right? Because that's just a good practice. You don't want to put something that barely works in this new feature and everything when you could let it polish and get really solid and have a really tight, strong 1.0. So we have a replicator configuration database patch that is coming in 1.1 thanks to Felipe Mignana and the other people on the dev list who've been helping him with it. It will make it so not only replications survive restart, but you can configure replications from a Couch app really simply and query the replication database to see which replications are running and what their status is and everything. So that's going to take replication and make it as easy to deal with as just a regular document. Oh yeah, these are all good questions. You guys are more advanced than I was expecting. So Tony, is it possible to restart replication without restarting CouchDB? I think it is. Yes, I'm not super that guy. Like I just restart my CouchDB because it's never really a big deal to me. But I think there is an endpoint or something you can post to the replicator to cancel a running replication. Sorry, I wish I could be like a walking reference encyclopedia for this stuff, but I just know where to look it up. So maybe a good place to ask about that would be on the IRC channel if you can't find something on the wiki. So bidirectional replication just works. I should have this white arrow in the middle. I should have that pointed in both directions, on my next slide. But I didn't want to dig too much into the details on that. It just works. Like Couch doesn't care. So you could have 3-directional replication if you want. You can do all kinds of stuff. And we'll dig into some use cases of that. So Before we look at replication use cases, I just wanted to show especially new people, maybe people who haven't played with it yet, um, the replicator UI in FUTON. So if you have CouchDB installed on localhost and you go to that URL, the _util/replicator URL, you'll see this screen where you can put in a local database or a remote database on both sides. Click replicate, and then it'll do the replication and report to you what the results were. So like in this case, you can see I have doc_write failures 1. It's like, I mean, maybe you can see that. It's the little tiny bit of JSON at the end of that yellow box underneath the replicate button. And that means that I didn't have permission to replicate one of the documents because I'm not logged in this screenshot. So I was unable to replicate the design document. You have to be an administrator to do that. So this is just FUTON. All this is a AJAX interface to the same command that we just saw on the curl screen, and then a nice little log of your replication history there on the screen. One other point I should make while we're just coming to understand the replicator. So CouchDB is modular, and it's very modular, loosely coupled. The replicator is practically its own piece of code. Like if somebody were to take the replicator and rewrite it or write port it to Ruby or Python or Node.js or anything, it'd be just as good. I mean, just as good. I mean, just as functional as the one we've got. It's nice to have it in Erlang because then you get all this reliability stuff, but it doesn't have a privileged position, regarding the server. So that means that you can replicate from remote to remote, which is pretty neat if you have a local replicator that you want to have actually doing the work, and you want to do credentials to your different remote databases, and you can. So I'm going to take these questions as they come up because I think that just works. Brian, is there a way to hide the password information instead of including it in the URL? Not on a remote. Right now, the password information goes in the URL. It goes in the JSON post. I mean, it's going to have to go in the JSON post anyway. So the easiest way to get in there is with the basic auth style URLs. Andy, basic auth over SSL, I believe so. I know there was some work on that in the last, in the run-up to the last thing. So that's Adam Kokolowski from CLOUDANT has been spending some time on that. So it's pretty simple. I think it was just sort of a matter of getting it to behave nicely when you've got an SSL proxy in front of it. So here's how that replicator call actually works. This is, here's my language of choice. I love writing little bits of jQuery JavaScript because it's so easy. So if you have your own Couch app, or you're running your own JavaScript served out of CouchDB's attachments, then you put code like this in there. The jQuery.couch.js is included in the CouchDB distribution. So all you have to do is load that up off of the same server that you're serving your HTML out of, and run a command like this. And this is going to trigger continuous replication between the source and the target. And the source and the target, again, could be local or remote. It doesn't matter. So that's how simple the API is. Now let's see what we can do with it. So read scaling. This is like the first. This is the first use case most people think of. Yeah, Daniel, that was probably a typo. I was polishing these slides up last night, so. SSL. Yeah, so to know about the SSL stuff, you really should check on the user list or something, just to be sure. So read scaling. This is kind of the most common replication topology that you'll see in, like, say, the MySQL world. Read scaling. Usually, what you'll do in MySQL is you'll have all your writes go to the master, and then you'll ship that log, that transaction log, across the wire over to your slaves, and then you can run queries on the slaves. And as long as all the writes go to the master and the logs don't get too far behind, then those slave queries should usually work. And if you're good at this, it's actually practical in the relational world. In the CouchDB world, it's just kind of so easy. All you're doing is triggering those replications and keeping them running. And then you can use an HTTP proxy in front of your cluster to send all the gets to the slaves and everything else to the master, and you're basically done. That's that topology. But now here's the caveat. The caveat is that, if you just want to scale your read load, just use an HTTP cache, because it's going to have a different, kind of interaction with the memory hierarchy. CouchDB almost doesn't need a cache as it is, but if you're like right at the edge of what your hardware can do and you have a cache handy, then yeah, it's just HTTP. We have E-tags on everything, so Varnish or Squid should do a great job, and does do a great job of taking the load off your disks if you're under a really heavy read load. So read scaling, pretty easy. I'm not going to spend too much time on that. This isn't going to be a webcast about setting up Varnish, but it's just works. It's just HTTP. So yeah, offline mode. This is really the heart of CouchDB's use case. So you've got your phone, you've got your laptop, you've got your cloud server, and you want them to be all in sync all the time. So as a change goes in on your laptop, you want it to come up on the phone right away. And say maybe you have a shared calendar that your buddies are all on. They don't all have to be on the same server, so everyone can have a copy of the calendar application running on their phone or their laptop, and they can work on it even when there's no internet or cellular access, and all your changes get persisted, and all the application logic is just right there. And then when you have a connection, like you come out of the subway tunnel, or whatever it is, then the replication will send those changes to the Cloud Couch and then back down to whoever else is continuously replicating with the Cloud Couch, and now you have a shared data set. What's really cool about this is that when there's no network like no network. I mean, just nothing is faster than localhost. So Google spends just all this money on getting their couches. They don't use Couch. Well, maybe they do. Getting their servers really close to their customers, right? Because that's what matters. They've found that every millisecond counts in terms of their revenue, because people are impatient and they click that link and they expect that page right away. And it doesn't matter how fast your server is if it's too far from the user, if it's too many network hops from the user, then that latency is gonna play a role. So having CouchDB right there on your phone or right there on your laptop, that's the fastest web app browsing experience I've ever had. So what you end up with then in a situation like this is everyone in your work group doing edits all on their local couches and synchronizing later. So what happens if I change the title of a support ticket at the same time as someone else changes the priority? So now you have these two incompatible changes, and one person did it on their cell phone, another person did it on their laptop. Later, when that stuff gets merged up through the cloud or directly, I've got that kind of grayed out arrow between the phone and the laptop because Couch works great for that. It's just kind of hard to address phones and laptops, unless you're both on the same local subnet. So you've got this, these changes that have happened in disconnected mode, and then when you're reconnected later, you're going to end up with a conflict state. Someone changed the priority and someone else changed the title. Or maybe even worse, maybe both people changed the title to different things. And so how does CouchDB deal with that? That's really the first question that comes to mind when I talk about replication. And this is how it deals with it. It basically does the only really simple answer. And so we've got these couches, A and B, that are replicating. We put a document on A, and now we're going to replicate it to B. So now that document is on both A and B. So now we're disconnected, and we do an update on B, and so now A and B are different. And that would be fine if we were to just stop right now and replicate back from B to A. Now A would have what B has because A hasn't changed since they became disconnected. But we're not so lucky. In this case, A is also changed. So now A is different. and B is different from what they were the last time they talked. So now we replicate again. What's going to happen, rather than CouchDB trying to psychically figure out your application and exactly what the best way to do that for your application would be, it just keeps them around. It has both versions now. The document is marked as being in a conflict state, and then you can get a view of all documents that are in a conflict state. Your application can iterate over that view and resolve the conflicts or present them to a user or whatever is appropriate for your application. For instance, in the BBC's cluster, they have a few clusters of like 8 or however many machines they're up to now in multiple data centers, and when they get disconnected, which happens sometimes, especially on a big news day under heavy load, then they may get updates to both clusters at the same time, and they wanted to have automatic resolution because they have so many users pouring updates into this all the time anyway. So all they do is they pick the most recent one, and that works for them, and they just wrote a script that does that. So if you want to do something, a heuristic like that, it's pretty simple to implement. Yeah, so if you were to replicate back from B to A after, once you're in this state, now A would be in the exact same state as this. That's what we call eventual consistency. So some of the other databases out there use eventual consistency as a catchphrase to mean do whatever you want and just kind of, don't sweat the details. CouchDB really means consistent eventually. And so in a replicating cluster mesh, what you're going to get is all the couches having the exact same state once replication has proceeded. And so, for instance, and here's another detail while we're looking at this screen. If you were to query B to load up that document, it's going to give you one of those. I can't tell, based on this picture, whether it's going to give you the musical note or the flower, but it's going to give you one of them, and that's deterministic. And so that means that if we replicated both A and B to couch C, it's also going to give you the flower. And if you replicate back from C to A, now A is going to give you the flower. They're both going to have them both there, but all cluster members are going to give you the same result. So this gives you, eventual consistency. And the same thing with conflict resolutions, they replicate as well. So let's see what that looks like. So I'm going to click this next button and see what happens. All right, so we resolved the conflict on B. We resolved it in favor of the musical note. And now that conflict resolution is going to, spread around the cluster. Ooh. All right, I'm backing up because we still have a couple of questions that are relevant here. Yeah, good questions. So the question about built-in versioning. There is a URL on the CouchIO blog, maybe someone can paste in the chat, that answers how to do built-in versioning. So the deal with CouchDB's storage engine uses multi-version concurrency control, and that that does a lot of things for us. It allows us to never block writes ever, and never block reads. So we're always just appending to the file. And that means, it also means that whoever saves first wins. So if I load a doc and you load it also, and we both make changes, and I save first, when you try and save, your save is going to fail for being out of date if we're on a single node. So we have this thing called multi-version concurrency control, but it is not the same as versioning, because in replication, only the most recent version of the document is passed around. Otherwise, the cluster would just grow and grow indefinitely in storage requirements. So we just pass around the head revision in replication. And when you compact the database, which is how you make up for the MVCC stuff by putting it all into a new file, it also only copies the head revision. So you can't use the built-in revisions for version control, but you can do this technique where every time you save a document, you take the old version that you loaded, that JSON string that came from the server when you first got the document, and just attach it as a binary attachment to the new version of the document in the same transaction that you update the document. So then you get transactional versioning. And it's you also get like a pretty nice little UI for it. Yeah, so the deterministic algorithm, we don't have a way for users to plug in their own algorithms. Part of the problem is that when you start to get sort of robotic conflict resolution happening around the edges of a cluster. Now all of a sudden, you might get flapping if, say, two of those robots were wrong or something. I mean, I guess then it's not deterministic, but we're pretty comfortable knowing that our algorithm is deterministic, and someone else might plug in an algorithm that's non-deterministic and blow their cluster up. So it's easy enough to use a changes listener, and we should probably do maybe next month a webcast on changes listeners to handle your conflict resolution. And so there's just like a whole bunch of ways that you can plug asynchronous processes into CouchDB, and a bunch of things you can do with that. Probably worthy of a webcast just as just as in depth as this is. So let's move on to clustered scaling, because at least in the wider world, out there on all the Reddits and such like, everyone wants to have something giant with more numbers than the other guy. Yeah. So maybe we'll do that next webcast on the changes listener. I don't know if, I don't know if we have another plan or not. All right. So fractal scaling. That's what we like to call it. I mean, consistent hashing is what it's called in the literature. But I think fractal scaling is kind of more fun, because once you start to see how it works in the CouchDB, since it really does make sense as a term. So fractal scaling. So consistent hashing, the way this works is you have some math, and just like a hash function like you'd use anywhere else, from the document ID to a number between 0 and 1. And then imagine that hash laid out around the perimeter of the ring there, with 0 and 1 both living at that blue line at the top. So now each machine you add to the cluster, you give it a fractional number somewhere in there. So if you had 8 machines, then you'd have them arrayed evenly around the ring. And now if you, when it's time to add a document, you hash its document ID to figure out which, where in that range it lands, and then, move along the ring until you find the next machine, and that's the machine who's in charge of that document. So that's just the real no-brainer way to partition evenly a data set. This is what, pretty much every clustering thing uses, at least, sort of as a baseline. You can do a bunch of performance and kind of operational things on top of this to add redundancy or add the ability to rescale your cluster over time. But just, to get started, first you got to grok this. It's just a deterministic mapping from a document ID to a home machine. And so in CouchDB, there are a couple of ways to to do this. The first one that came along is called CouchDB Lounge, which the Meebo chat website, they need to, they use CouchDB, and they have lots and lots of big numbers, people putting stuff in there, reading it. They're, millions. I don't know how many millions, but maybe someone in the chat who works there will put a number on the millions. I'm probably being modest in terms of how big their deployment is. So CouchDB Lounge, it's all in the HTTP domain, and that's kind of what I like about it, is that it is a proof of concept as well as deployed running production code. It shows that you can cluster CouchDB, pretty much as big as you want using just web stuff. So it's the program has two components. It's got the dumb proxy and the smart proxy. So the dumb proxy picks, for each document, does it go on machine 1, 2, 3, 4, however many machines you have. Yeah, so it's just the hash table lookup key trick is just order 1. It's just a hash. I mean, if your hash table gets real big, maybe you're going to want to start storing that in a B tree, but hopefully your hash table is not that big, right? The thing that why I call this fractal scaling is that we've got here on the left-hand side a cluster of depth 1, right? And so the thing that can happen is you could start to outgrow that cluster. Like what if that wasn't just 4 machines on that cluster of depth 1? What if it was, 32 machines, and you didn't want to add another member to the ring, or maybe for some reason your hash algorithm wasn't well spaced, and so now machine 3 is coming under more load than the other machines. So what you can do is you can start replacing, because, well, I'll go back to the beginning on this. You got smart proxy and dumb proxy. Dumb proxy hashes the documents. Smart proxy makes it so views work across this cluster. And then the upshot is that when you're done, you've got something that looks pretty much just like a CouchDB. It's got its own URL running through those proxies, and you can run the CouchDB test suite against it, and it basically works. I mean, it works good enough for Meebo's production use. So now, since it just looks like a CouchDB, you can use CouchDB Lounge to cluster CouchDB Lounge recursively, and so you end up with a deeper cluster. So that's what that picture on the right-hand side is. We're just zooming in on a lounge that is a member of a lounge. And so what you're going to get is, Brad's right. You're going to get order log n scaling, where the base of the logarithm is the number of members in your hash rings. So it's going to add a little bit of latency to requests, but you can run the proxy, the smart proxy and the dumb proxy, in a redundant configuration because it's stateless. So you can just run a bunch of them and load balance across those and take this thing up to millions of requests a day. So Sam, great question, operational question. Some of the things that CouchDB Lounge takes care of for you, it takes care of the views and the design documents. So it looks just like a couch from the outside. So it knows how to do things like you deploy your design documents to the lounge. It knows design documents always get pushed to cluster member 0 first, and then it knows to replicate the design documents to every cluster member. So that just works. And so that just sort of another thing Lounge takes care of for you, and something else that's simple because of how CouchDB works. The other nice thing about this, of course, you can use the offline style replication to add read redundancy or write redundancy to this system. So each one of the machines in a lounge can have a twin that is kept up to date using replication. So if one of them dies, you can just fail over to the other. So fractal scaling, I mean, I don't know, just it's cool. Just more lounges. It's lounges all the way down. And there's something else exciting coming up soon called Open CLOUDANT, and that is, we're talking about that in the chat a little bit here, and it's a whole more kind of technically integrated with CouchDB. It's written in Erlang, and since Erlang is designed for these distributed systems from the ground up, it can do these these hash lookups like we were talking about, but rather than using an HTTP proxy, it just hands around Erlang objects essentially to the proxy has an Erlang object that the file pointer on it is basically pointing to a file on one of the edge nodes. And Burad can tell you more about it. I think he had a hand in writing the thing. So we're really excited to get that contributed back to the community. It's also got the quorum system that Cassandra is so famous for. The whole talk's going to be online, and it might take up some time. So it's got the quorum system, so you can say a write doesn't count until it's been written to 2 machines or 3 machines or however many. And when I do a read, check 3 machines and make sure that read is available. Is the same on all 3 machines. So you can do all these kind of consistency tunings the same way that you would do with Cassandra. And I think that's going to be really big when it hits, partially because some people really do need to scale, but also because, if you're going to make an investment in a technology, you want to make sure that it can carry forward with you, even if you do grow unexpectedly. And so between Lounge and Open CLOUDANT, I think we're going to have a really strong scaling story for scaling up. It's an exciting times. Let's see. What do I have next? Ooh, filtered replication. We got here on time. I'm a happy guy. So when you do replication, there is, you can do some, you can write a JavaScript function that tells the changes feed, which powers replication, to include or skip some items. So for instance, if you were writing, let's just take a step back from this exact use case and just give you a little bit more background on the changes feed because it's kind of important. So changes feed powers replication. It's just a comment feed where when things happen on the database, every time there's an event on the database, you get a new line of JSON on this HTTP socket. So imagine all the fun stuff you can do with that. All right, that was fun. You imagined that. Yeah, you can do that stuff. It works. So if you write like a chat application or something in the browser, it can just hang on to that changes feed, and anytime something comes down the line, it can print it to the screen. So it's pretty trivial to write chat applications, things like that. If you go to couchapp.org, you can find out more about that, but that's aside for this talk. So you got the changes feed. You got, and then there's a parameter on it. So you're writing this chat application, and at first it was all one room, but then you decided that you wanted to add multiple rooms, or say maybe the ability to ignore certain participants, or whatever you want to do. So you can write a JavaScript function that has that gets the document that's associated with the particular change, as well as information about who is making the changes request, and that function can return true or false. So if the function returns true, then that document goes in the changes feed. If the function returns false, it doesn't. Pretty powerful. You can use it for doing things like repairing clusters or rebalancing clusters. You can do it for things like selectively listening to just some messages on a chat server, like just the messages from the room that you're in. And you can also do it for this really cool use case, secure data sharing and collaboration. So Assay Depot is in the pharma industry, and they work with other pharma companies that, they don't do lab work. They help people who do lab work collaborate. And so you may have, two big pharma companies, and they're huge competitors. They're cutthroat. They're always trying to get to market first with the same thing. Yeah. I wonder if farmers have this same sort of thing going on. So pharma companies, pharmaceuticals, I guess is how you say it. They go to Assay Depot and they describe the services they offer. So there's just so much lab work that goes on. It's like, take this culture that we made and expose it to a matrix of these three chemicals across a gradient of concentrations, and I want to hit that gradient evenly spaced in that three-dimensional space, and I want to do 10,000 assays, right? So it's like a big industry. And this is just once you get this set up, it just looks like replication, except for it's partial, it's not everything. So in this use case, what they do is each of their customers, and I don't know which customers they've got the rights to brag names about. So I'm going to call one of these pharmaceutical companies, I'm going to call them McDonald's, and I'm going to call the other one Burger King. So you've got McDonald's, and they need this lab work done. And you've got Burger King, and they've got these idle labs. And it's kind of like open source. Like some of this work is just, it's not really a differentiator between the companies. So they're willing to outsource it even to their competitor. But then, also Burger King may have another lab which isn't idle and does their top secret work. But they even use Assay Depot for internal communications between, their research team and their assay team. So they can drop in one document that says, "Hey, I need this lab job done, and by the way, like anyone who wants to fulfill that lab job, I'll do it." But then their top secret lab with their really cool new thing or whatever may put in another document that says, "We need this lab work done, but this one's strictly confidential and it can't leave the organization." And then there can be a third document that's dropped in the Burger King database that says, this is confidential but not strictly confidential. So, internal Burger King labs can offer to fulfill this work, or we have a few trusted partners who can offer to fulfill this work. And so then the Burger King database is offline. It's under, it's full control by Burger King. They just put whatever they want in it. They replicate it to Assay Depot. Now Assay Depot is, is trusted to use filtered replication to take the stuff that McDonald's is allowed to see and replicate it to McDonald's, and to take the stuff that the trusted partners are allowed to see and replicate it to the trusted partners, and to provide a cloud hub so that the internal top secret lab can replicate down and see what work needs to be done internally. So that is that's just the use case, and we're going to dig into the technology of how to do replication in about 5 seconds after I close my window because the garbage man is coming by. All right, I'm back, and let's talk about how you triggered filtered replication. So this is what a filter looks like. There's a blog post here that explains it in depth. So it's just a JavaScript function that takes a document and a request, and it can do whatever it wants, and throw errors or return true or false. So if in this case, what we're doing is we're only asking to replicate documents where the username matches the query name. So then anyone who's replicating can say, hey, I only want documents from jChris, and this filter will do that for them. So first couple of things we're doing here, just a little bit of error checking so that we can throw an error if they have a malformed query. Then the last couple of sections at the end are the actual filter. So all we're doing here, this is a one-liner, if the document.username equals the request.query.name, then return true. Yeah, okay, this is a good question from Brian. And then otherwise, in this case, we just return false. Yeah, so these are good questions coming in. I might get to some of them later. Yeah, so filtered replication works the same as regular in the sense that you run it once and it replicates, passes over the whole DB, and then you run it again and it picks up where it left off. So each time a replication job is triggered, there's a signature which describes the job, and the signature determines what sequence number it picks up as of. So if you change the filter or you change the query, then it's going to pick up from the beginning again. There is a, it fits in the model, patches welcome, to have, start from X, where X isn't the beginning of time. So more good questions coming in. So Andy, is there a way to delete info after it's been replicated to the remote DB? The answer is you don't want to do that because the deletes also replicate. So, I mean, maybe if what you want to do is replicate it on the remote, they're deleted on the remote also, then if you do a local delete and replicate again, it'll do a remote delete. So hopefully that answers your question. So let's see. I'm going to next slide here. So this is how you would actually trigger that filtered replication. So here's what you're doing is, just like we saw before, you've got a source URL and a target URL, and then you give the name of the filter. So that filter function gets stuffed in a design document just like a view definition. So in this case, the design document would be _design/example. And then in there would be a member called filters, and one of the filters is, in this case, named filter name. So now we're going to run filter name, and the query params is going to be, !name equals Pete. So now we've got the replicator on 127.0.0.1 is going to query its local database, and it's going to ask for that changes feed Just say changes, question mark, filter equals, blah, 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 ampersand, name equals Pete. And so now that information is available to the filter function, and you're going to get that subset of the database. So in order to do the secure use case, the Assay Depot use case we talked about, you do need to have a controlled hub because, right now as it stands, there's no way built into CouchDB to enforce who's allowed to run which filters with which query parameters. And so that's the kind of thing that you would need to have a centralized hub and then create the owned DBs. So like create the Burger King DB at Assay Depot and give Burger King unfettered access to that DB, but you can't just sort of trust Burger King to replicate filtered from the main database. So that's why Assay Depot, that's sort of their business, is managing the trust model here. Yeah, so the standard filter, Daniel, is true, return true. Send everything. So I hope that answers your question. So I think we're coming up on the end of the prepared remarks here. Let's see what we've got. Yeah. Oh, good question, Jeffrey. The logged in user is available in the request object. I think it's rec.userContext. No, Matthew, Ubuntu 1 has their own authorization system where each user just gets their own whole database. So they don't actually ever merge your data with anybody else's data on their server. So they don't need to use filtered replication. So Tony, there's no, you just want to force a replication filter all the time. Is that what you're saying, Tony? So there's no way to do that. That's why Assay Depot, runs as a trusted hub. So you can force it inside your, inside your firewall, and then only provide access on the outside to people, to their own database that you control the replication into. Alexander's question. Will the way to do it without database splitting? Well, so Alexander, I'm not sure what the abstraction looks like inside OpenCloudant, but at some point you're going to have different physical disks with different files. And in CouchDB, each database is one file. So at some level you're splitting databases, but logically, the way it looks to an API client is as though there is one database. So I hope that helps. So here's some resources. We've got that CouchDB Twitter account. I'm kind of surprised if you didn't see that earlier today. We've got the CouchDB official website. If you want to download binary installers or get free hosted CouchDB in the cloud, we're doing a beta program at couch.io/get, and that'll allow you to sign up. Your couch should be ready basically instantly. We're probably under a bunch of 10x load factors right now because of the 1.0 release. So if it's sluggish, please be patient. It'll be fast tomorrow. It might be fast right now. Jason's kind of a badass. So what else do we have? We've got planet.couchdb.org, which is all the blogs. And thanks, Jason. And we've got the book, which is available for free. That was the original, the draft version. If you go, if you want the fancy, good figures and copy edited stuff, then you should go through the O'Reilly site to get it. And if you're, I'm kind of happy about the O'Reilly. They've got a version of the book in the App Store on iPhone and on Android. And that's a pretty nice little e-reader. And I think it was smart of them to just sell each book as its own application rather than, messing around with trying to get it into some book reader application or something. Kind of don't understand why all these book publishers want to get in the book reader when it's just easy to write a little app that is the book. But that's its own talk. So thank you for hanging around, and please ask more questions if you've got them. I'm going to put up this last slide here, which is just, a picture of a phone with a couch on it, because if you missed it earlier, I want to reiterate, go to the Android marketplace and search for CouchDB. You'll find that book I just talked about, but you'll also find a local installer for CouchDB, so you can run it right there on your Android phone. That's a dev preview right now, so we really appreciate feedback on it and making sure that it's solid and easy to understand, and that the upgrades all work, and stuff like that. Like, I think we just added yesterday the ability for you to use host names in the Android replicator rather than having to replicate by IP address. So it's definitely a dev preview on Android, but it's the same old CouchDB you know and love, and your Couch apps will run right there. And if you can figure out how to get your Rails app to run under JRuby, and your Rails app uses CouchDB, well, now you've got your Rails app on your phone. So I hope that's exciting for folks. Yeah. Let's see. Russell's asking what Android release is required. I think it's 2.1 or 2.2. Yeah, it takes about 20 megs or so, all told, 17 megs to do the install. So I don't know if that's a lot or a little. I mean, I've got podcasts that are bigger than that. Yeah, thank you everyone for coming out. Andy wants to know if anyone's used AREL for querying CouchDB, and I don't know what the answer is to that. For the Apple thing, this is doable. Yeah, so getting the Couch on the iPhone, I mean, if you're willing to jailbreak, I don't think there's much in the way of a challenge. It's the same ARM architecture that, the Android's running. It's Darwin, at the bottom, but you're going to have to jailbreak for now. And there are some challenges to getting it to, just run on the phone. I think the big challenge is the sub-process limitation. I mean, the background thing notwithstanding, CouchDB runs as, a collection of processes because it's a Unix program. That's how those work. So getting that, kind of packaged up in a way that's going to work on the iPhone is something we're looking into. But, it's a little bit of a technical challenge. So thanks everybody for coming out, and have a shout out for 1.0. I'd say if you can, go out to the pub tonight and tell your friends, tell your hacker friends to come out and have a drink for CouchDB or whatever it is you do for fun. Maybe tweet your CouchDB meetup photos or something, and probably after the fact we'll think, hey, that's a good idea. We should send all the people who did those meetups T-shirts or something. So yes, it's written against the NDK. You should talk, if you're interested in the Android dev kit, you should talk to apage43, Aaron Miller on IRC. He put that together because he's good at that sort of thing. So yeah, thanks everybody. I hope this was informative. I kind of wish I could have dived in deep and shown you running the replicator and stuff, but I think you probably learn more from getting the survey of it. And then if you've got any questions, if you get down to replicating and you hit anything, it's probably our fault, but we're not going to know about it unless you tell us. So come to the dev list or the user list and say, hey, it broke when I was doing this, because the only way we learn about those things is when people tell us. So thank you very, very much. Yeah, let's talk about 1.0. We've got a couple of minutes left. 1.0 is pretty solid, pretty simple upgrade. It should just if you have Couch running on 0.9 or earlier, I think you should just be able to boot 1.0 up against those files and have it work. It'll upgrade the files when you compact. Yeah, 1.0 will build on Windows. You have to build it yourself right now, unless since I started this screencast, somebody did a Windows build and posted it. So we're working on it. Hopefully we'll have a binary installer by the end of the day. But right now we're still waiting on that binary installer to, come sliding through. Good question about 0.11, 1.0 on the same day. The reason why is because why not? So we backported a bunch of the stuff that is in 1.0 to 0.11.1. There's a couple little things that are in 1.0 that aren't in 0.11.1. And 1.0 is a little bit faster. But yeah, that's the one issue that kind of makes me a little bit sad, is that in order to replicate with 1.0, you need to be running at least 0.11.1. And so if you look at the breaking changes page on the CouchDB wiki, it'll document that. There's a good reason for that, and we'll have more info about that soon. So yeah, the replicating from 0.10, if you use the 1.0 replicator, you should be able to replicate from 0.10 or 0.11.0 just fine. It's just if you use the older replicator to try to push to 1.0, you're going to get errors. So Nikolai, yes, 0.11.1 will just plain open those 1.0 couch or those 0.10 couch files, and they should be able to replicate. Actually, I think 0.10 you're going to want to push to 0.11.0 and then upgrade to 0.11.1 and then push to 1.0. But all that sounds way too complicated when you could just boot 1.0 on your 0.10 files and have it work. If you're going to do that on production data, test it first, please. Don't come to me and say, "Oh my gosh, it broke." I mean, I've seen it work. I'm fairly certain it works, but it's your data. Yeah, thanks everybody, and welcome to 1.0.
Hey, thanks, Chris, and I want to thank everyone else too for joining in the webcast today. It was a great webcast as always, and we'll have another one in August, I believe. We haven't set the date yet, but keep your eyes open for it, everyone. And congratulations, Chris, on 1.0. Very exciting. And that's about it. I'm going to wait a couple of minutes, count from 10 to 1, and then close out the room. So thanks everyone for joining us. And I also, have one last thing. The URL for our survey, if you could give us some information, some feedback in the post-event survey, would really appreciate it. You'll probably get an email in about 12 hours with the link to the survey too, and we'll get the recording out to you in a day or two as soon as we have it ready. So again, thanks everyone. We'll count down and close the meeting.
Thanks everybody. I just wanted to mention because of 1.0, and there was already like a Hacker News meetup happening tonight in Berkeley at the Jupiter. So if you just type Hacker News Jupiter into Google, you'll get that page and the info on how to get there. So if you're in the East Bay and you want to come out, I'll try and have a stack of CouchDB t-shirts, and we can meet up and it'll be fun.